Hello everyone, my name is Joshua Ajetomobi. Today I want us to look at principal component analysis in R. Then later we are going to look at factor analysis. PCA allows us to visualize the variation present in any data set, particularly when we are dealing with many variables. The ideal is to turn the PCA variables into what we normally describe as principal components. We show directions with the most substantial variance that are present in the data set. We normally use two parameters in order to deal with the dimensions of the data set. One is the eigenvectors and the other is the eigenvalues. The eigenvectors measures the direction while the eigenvalues measure the variance that are present in our data sets. Generally, principal component analysis works only with numerical variables. So in our illustration, we are going to make use of a data set which I named PCA.dat, and I save it in COVID-19 folder on my desktop. It contains 7 different variables. We have country level COVID-19 infected cases, number of deaths, corruption perceptive index, human development index, the rank of human development index, doing business index for 2019, and doing business index for 2020. For us to carry out our principal component analysis using R software, here is the procedure that we need to follow. The starting point is to set our working directory and import our data. Then we make use of 3 different R packages. We have factor extra, factor minor, then plot. It is relatively very straightforward to run principal component analysis using R. We just need the function PCA. I named the output PCA new, so we just say PCA, then we put our data set, which is PCA.dat in brackets. And in order to obtain a table of our eigenvalue, I named the table PCA underscore tab, and I type PCA new $, then $ will give us a series of functions, and we are going to pick AIG, which stands for the eigenvalue. Then after doing that, we now type the PCA underscore tab in order to produce our eigenvalue table. And here we have the table. Remember, we have 7 different variables, which means we are going to have 7 principal components, which are component 1, component 2, up to component 7 here. Each of these components explain a percentage of the total variation in our data sets. For instance, if you look at component 1, under percentage of variance, we have 63.56. This implies that 63.56% of the total variance in the data sets is actually explained by the first component. Then the second principal component explains about 22.93, and cumulatively, component 1 and 2 explain about 86.5% of the total variance in our data sets. Another very good way of illustrating our principal component analysis results is by the means is through the use of graphs. And there are 6 common plots that we normally use. We have the screen plot, the profile plot, variable contribution plot, pattern plot, score plot, and the bar plot. In principal component analysis, most of the variance in high dimensional data are captured in a lower dimensional subspace, covered by very few principal components. In fact, the essence is to generate few principal components. So we have one big question to answer anytime we are performing principal component analysis, and that is how many principal components should be retained. And this is where screen plot is very, very important. The screen plot at a go is going to show us the plot of our eigenvalues of the correlation matrix. And generally, it's going to order the matrix at the values from largest to smallest. And this is the function to do that. We are going to illustrate it later. If we have done it correctly, this is what we are going to obtain. And clearly, it's showing us that principal component 1, principal component 2 explain more than 85% of the variation in the data set. So in terms of plots, another plot is what we normally call the profile plots. The profile plot shows the correlation between each principal component and the original variable. And this is the code to generate it, very straightforward. Here we have our 7 different variables, tk, tdet up to hdi. And these are the principal components. So we can see that there is a very high correlation between tk, tdet, and pc2. Suppose 0.80, 0.79. Generally, each principal component is a linear combination of the variables, our variables of interest. So we generally want to know the contributions of the variables to each of the PC. And now that we have identified 2 principal components of interest, because they actually explain more of the variations inherent in our data set, so we want to look at the contribution of the variables to PC1 and PC2. In order to do that, this is just the code. And here we have the result for PC1. And here we have the result for PC2. Then we have what is called pattern plots. If we come here, which is our profile plot, we will see that instead of having dimension 1 to dimension 7 here, some are actually not showing. And that is even in the situation where we have just about 7 variables. What if we are considering about 20 or more variables? So this is why it's always good to show the pattern plot, which is going to show us in a circular form. It's performing the same role as our profile plot. And usually there are n into n minus 1 divided by 2 pairwise combinations. For instance, we have 7 different variables, so we have 7 into n minus 1, that will give us 6, 7 multiplied by 6, 42. Divided by 2, we have 21 different combinations. And this is the results. And we can see clearly the pattern. Then we have what is called the score plot. The score plot indicates the projection of our data onto the span of the principal components. So in our situation, we have about 153 different countries. So we run it, and it's going to project each of those countries into the span of our principal components. So if you try to do that, then we have this. But if our interest is just the variables, Then I've shown us what we can do, but we can still use this code also, which is going to show us the same thing. This is the result I've shown us before. But in a situation whereby we combine the variable and the nation in our own situation now together, that is what is normally described as biplot. This is the code to generate that. And here we have our biplots. This is the code to use to generate everything that I've just discussed. And in case you want this code so that you can try it with your own data sets, you can contact me on my email, or you inbox me, or whichever method. If you want it, I will send it to you. There is no problem about that, so that you try and be sure that you understand how to use it and how to explain it. And like I said earlier, this is not a replacement for the theory. You still have to go through the theory and understand the principle very well in case you want to make use of it. So thank you very much. Now we are going to go to our R Studio. So let's open our R Studio and illustrate everything that I've said. Like I said, the starting point is to set our working directory. So let's set our working directory. Here I say choose directory. COVID-19, which is in my desktop, is the folder which contains my data sets and where I want my research to go. So I say open. So then let's come back here. We have file. The data set of interest is PCA that. This is the data set we want. So let's import the data set. So let's import. So we have our data set. So let's come to our script file. Like I said earlier, here we have the 3 different packages. Let's run it and be sure we have all of them. That's fine. So in order to obtain our eigenvalue table, we need just these 2 lines. So let's run it. So the moment you run it, you will see this is PCA underscore tab. So this is it here. Then you can click on this to show you. You can see clearly. Then you can say select all. Then you copy. Then you can now place it in your Word or Excel or in whichever place where you want to place it or your presentation. So let's go back to our script file. In order to get our screen plots, this is what we need. Just run this, get the screen plots directly. So this is our screen plot. You can zoom so that we see it clearly. Then you can now copy it as image and take it to your Microsoft Word. So let's close this. And in order to get our profile plot, we need these 2 lines. So let's run it. So run this. So this is our profile plots. And in terms of contribution plots, contribution to the first principal component, we run this. Yeah. And for the second, we run this. Remember, we are changing the axis now to indicate our component of interest. So we say run. Yeah, that's all right. So that's it. So if we want to get the score plot, so we run this up to this place, the score plot that is projecting our individual nations to different principal components. So we run this. Okay. Yeah. So the result is taking time because we have about 100 and oh, sorry, I've copied up to this, but the results It's already out. Okay, this is the results. Sorry. Okay, this is the results. Okay, let me run it again since so that we can have this run it here. It's up to this place here, the first one. So we say run. So whenever we see this red mark, we have to wait until the result is out. Yeah, because it's actually, yeah, now the results will soon show up. Yeah, so this is the results. Then you can see it's very crowded. So in order to see clearly, it's good to zoom. So let's zoom it. Yeah, you can now see clearly projecting. And usually our interest most of the time is to look, well, for the outliers. Yeah, yeah. So, but if our interest is just the variable, we have done it before, but this is another way to do it. You can just run this very fast. Yeah, so again, you can zoom to see it clearly. Yeah, we have seen it before, so that's all right. So, and if our interest is by plot, that is now we are combining the score plots as well as um, our pattern plots. So we run this. So yeah, result will soon come up. So let's wait for the results. Fine. So now let's zoom in. This is our biplot. We zoom in order to look at the results uh, very clearly. So this is our results. So thank you. This is just what I want to show us today. Next time we meet, we are going to be looking at the other aspect, which is factor analysis. Until then, stay well and keep fit. Thank you.